Trigonometry in right-angled triangles. 2017. It is given that triangle PQR below is right-angled at R, QR equal to 4 centimeters, and tan QPR equal to 4/3. Like that. Find sine PQR. Find sine PQR. Since this one is a right-angled triangle, Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares of the adjacent sides. Now, tan QPR is equal to 4/3. Tan is opposite over adjacent. So tan QPR is where we have the angle in the middle there at P. So this angle tan QPR is opposite over adjacent. Our adjacent is PR, meaning our PR must be 3 centimeters. So we are going to say, since tan theta equal to opposite over adjacent and tan QPR equal to 4/3, then PR equal to 3 centimeters. And then the Pythagoras' theorem states that the square on the hypotenuse is equal to the sum of the squares of the adjacent sides. So PQ squared should give us 3 squared plus 4 squared. So we are going to say PQ is equal to the square root of 4 squared plus 3 squared. When you square PQ squared, it should give you 4 squared plus 3 squared. Introduce the square root on both sides. Our PQ will be equal to the square root of 4 squared plus 3 squared. Our PQ will be equal to 25. If you square 4, you get a 16. If you square 3, you get a 9. 16 plus 9 will give us a 25. The square root of 25 is equal to 5 centimeters. Now the question is saying find sine PQR. So where there's PQ, we'll replace a 5 centimeters. Therefore, our sine PQR will be equal to 3/5 because sine is opposite over hypotenuse. They are saying find sine PQR. So we are looking at that angle there. So which side is opposite this angle Q? It is a 3. Our longest side is a 5 centimeters. Therefore, our sine PQR will be equal to 3/5. 2018. In the diagram below, AC equal to 10 centimeters, angle ABC equal to 90 degrees, and angle BAC equal to 30 degrees, like that. Calculate BC. Calculate BC. Since we've been given that angle there, we can always use sine because we have been given the longest side, which is the hypotenuse. So we can always say sine 30 degrees must be equal to BC over 10 centimeters. So we are going to say sine A, which is a 30 degrees, is equal to BC over AC. So we'll apply our SOHCAHTOA, which means sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So sine 30 degrees is equal to BC over 10. Take note that sine 30 degrees is a special angle, which is 0.5. So where there's sine 30 degrees, we'll replace a 0.5. So we are going to say 0.5 over 1 must be equal to BC over 10. And then we are going to cross multiply. So when you multiply 0.5 times 10, you get a 5. Therefore, BC is equal to 5 centimeters. 2019. In the diagram below, BCD is a straight line, AB equal to 12 centimeters, AC equal to 20 centimeters and angle ABC equal to 90 degrees, like that. Find the value of cos ACD. Find the value of cos ACD. So we are looking for that one. So what we are going to do is to find the cos of ACB, and then we know that this one is less than 90 degrees, but we are looking for cos ACD in the second quadrant. So we'll take it step by step. We are going to say Pythagoras' theorem states that the square on the hypotenuse is equal to the square of the adjacent sides. So our AC squared is equal to AB squared plus BC squared. When you make BC squared the subject of the formula, it means our AC squared will have to be subtracted minus AB squared. So we are going to say AC squared is equal to AB squared plus BC squared. Our BC squared, when made subject, will be equal to AC squared minus AB squared, and then we are going to substitute. Where there's AC squared, replace a 20 squared. Where there's AB squared, we'll replace a 12 squared. 20 squared is the same as 400. 12 squared is the same as 144. So we are saying BC squared equal to 400 minus 144. Our BC squared is equal to 256. To find the value of BC, introduce the square root on both sides. Our BC is equal to 16 centimeters. From here, we are going to say cos ACD is equal to BC over AC. Cos AC, we are looking at that one. Cos is adjacent over hypotenuse. Our adjacent is a 16. So where there's BC, we'll replace our 16. Our longest side is a 20. Take that to its lowest terms. 4 into 16 is a 4. 4 into 20 is a 5. Our cos ACD is 4 over 5. But we are looking for our cos ACD, which is in the second quadrant. In the second quadrant, cos is negative. So we are going to say, therefore, cos ACD is equal to a negative 4 over 5. Take note, since angle ACD is in the second quadrant, then the cosine ratio must be negative. As simple as that.